Okay, use 3 iterations of Newton's method to approximate the real zeros of each function. Okay, so here is this weird process, and you might have a professor that wants you to get, you have to keep not three, but you have to maybe get within this close of approximation. One time I had a professor it took 2 full pages of repeating the process and with writing small over and over and over again. Yeah, it was a headache. So I'm going to show you the process. I pre-wrote it down here. So that's the formula right there. So the new guess is equal to the x naught subtract the original function divided by the derivative function with the x naught put in the function. So x1 is equal to x naught minus f of x naught divided by f prime of x naught. All right, so you have to find the derivative, which is 5x to the fourth minus 12x squared plus 5. So x naught is equal to 0. So that's going to make this process a little bit easier. So then we plug it in. Let me move this up a little bit. I'm actually going to move this over. There's the formula. All right. I want to make sure that's a subtract note. Yep. Okay. So and I think that in Thinkwell they have a video of this. Go ahead and watch that. If not, find Patrick JMT a video. He might explain it further. So x naught is 0. Subtract f of x. But remember, with x, so 0 to the fifth minus 4, 0 to the cubed, even though we know all of those are going to be 0. Subtract 1. So that's going to be negative 1 over f prime is, this is going to be in parentheses, okay, so this is going to be 0, subtract negative 1/5, which is 1/5. So x sub 1 is 1/5. All right, so now, okay, so our x1 is 1/5. So now you have to do the second iteration. You find x2. So x sub 2. So that's equal to x sub 1 subtract the function at x sub 1 over the derivative at x sub 1. So x sub 2 is equal to, did we say that was negative 1/5? That's subtract a negative, so that's positive. Okay. So 1/5 minus, and we've got, oh geez, this is a hassle. 1/5 to the fifth minus 4 times 1/5 to the third plus 5 times 1/5, subtract 1, all over 5 times 1/5 to the fourth minus 12 times 1/5 squared plus 5. I'm going to let you finish that one, and then that will be the x2. So x3, the third iteration, will be the x2 subtract. So if you're putting in a calculator, you would have to do this. If you do it individually, then yeah. But if you type it all in just like that, you should be okay. So it's x2 minus f of x sub 2 over f prime of x sub 2. And that would give you, that would find the third iteration that they're talking about. Okay, and I think, oh, maybe I did it here. Yeah. So by the way, instead of 1/5, just put it as 0.2. So instead of 1/5 here, silly me, instead of 1/5, just put 0.2. That'll be much easier for the calculator or for typing because it's fewer keystrokes. There you go. So once you get that, and then what did we have? It was this right here, about 0.206996. Then that's what goes there. Use the store feature on your calculator in the memory, and then you don't have to retype that so many times. So it looks like, there we go, x sub 3, and you're going to want to go out. I went out 6 spaces past the decimal. You want to go out pretty far. So you're not going to round that to even the thousandths place. You're going to go out 5 or 6 places. And I think, I don't know if I did another one. I'll do one more video on this. All right. Thought I was done, but L'Hopital's rule.